Hello, this is Mr. Payne with another fabulous IXL tutorial. Today we're working on IXL W.3, model and solve equations using algebra tiles. So what this IXL module is going to do is it's going to ask you to identify the equation from the algebra tiles. Then eventually it's going to ask you to switch where you're going to go ahead and create the equation from the tiles. All right, let's take a look and see how this one works. All right, so one thing we got to do right now is figure out what a negative x and a negative 1 really means. First of all, a negative 1 or a negative any number is called a constant. It's a constant because it's a number that doesn't change. Now, this first tile, if you notice, is a different size and it's labeled as negative x. The negative x, or the x in itself, is called a variable. So what we're going to do is we need to keep the variables and the constants separated. You can't just say this is negative 3x. It doesn't work like that. So starting with the first tile, we have only one tile that's negative x. Then our next one, grouped together because these are all the same, are negative 1, negative 1, negative 1. Well, negative 1 subtract 1 is negative 3. So what I'm going to do is I'm just going to bring these down as I go. Okay, the first one, negative x, is just there by itself. So I got negative x minus 3. Bring down the equals. And now I'm going to count down the number of tiles that also have negative 1 on the right side. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So negative 1, subtract negative 1 10 times will give you negative 10. So now what I'm going to do is I'm going to compare my equation with the ones at the bottom. So notice that negative x minus 3 equals 19 is very close, but that positive 19 is not correct. Negative x plus 4, I'm not sure where they got the plus 4 from, so that doesn't work. The next one is we got negative x plus 4. Again, plus 4 is not part of the equation. And it looks like our very last equation, negative x minus 3 equals 10, has a perfect match. So we're going to go ahead and select that last equation. So again, we're just matching the tiles to the equation. We have a negative x, perfect, negative x. There's negative 3 on the left side, 1, 2, 3, that's negative. And on the right side, negative 10 with all the negative ones added up together. All right, so I'm going to select the last one, be on our way, get some points right here. And now it looks even more difficult, but you know what? It's actually almost the same thing I've been doing. All right, so the first part here is we are looking for 4 tiles of x. So notice 1, 2, 3, 4. We got 4 tiles of x. Looks good there. The second one down, we got 1, 2, 3, 4, 5 tiles of x. So the second one is out. See how fast it is to go through these really quickly. The third one down, we got 4 tiles of x. So that one could be a correct answer. And the last one, we got 5 tiles of x. So that's not the correct answer. So now we have to use our 32 on the right side to see that there's 32 ones. So starting with the first one, we're going to go ahead and count up our ones and see if we got 32 of them in there. So here we go. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Now, to me, that looked like a perfect match. And it was kind of a handful to count all those tiles. So what about another way of counting it? So what I'm going to do is I'm going to call this a 3 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what that means is we have a 3 by 10. So 3 times 10 plus the last 2 that are left out will give us a final amount. So if you didn't want to count them all out and you're like, you want to look for a pattern, I would use this. So 3 times 10 is 30 plus 2, and 30 plus 2 is 32. So we know that one's going to be correct. So our third option here is way too short. There are not 32 tiles in there, so that's not going to work. So in this particular case, the first option is going to be our correct option. All right, which set of algebra tiles represents the equation x plus 8 equals 17? So the first thing I'm going to check is make sure we have 1x. 1x, 1x, 1x. Okay, so all the green tiles match. So far, so good. Next thing I'm going to check is for 8 ones tiles. So the first one we have 8. The second one we have 8. The third one we only have 4, so automatically out. And the last one we only have 4 on the left side as well. So now we're 50-50 choice. On the right side, we're going to check for 17 tiles. So let's go ahead and check the first group. So what I'm going to do is I'm going to use my multiplication rules. So I have 3 times 5, which is 15 in here, plus 1, 2, plus these 2 here. And there we go. We got our 17 there. Now, if we take a look at our second option here, we got 3 times 1, 2, 3, 4, 5, 6. And 3 times 6, we actually have 18 in that group there. So therefore, the second option doesn't work. So we're going to go ahead and pick the first option on that one. All right. Which equation does this set of algebra tiles represent? Okay, the first thing we're going to start with is our negative x tiles. So we have 1, 2, 3, 4 sets of negative x. So we got a 4 there, looks good. Negative 4 there, looks good. Negative 4 there, looks good. Negative 4 there, looks good. So no elimination quite yet because the negative 4x has worked out perfect. Then we need to subtract 1 and subtract another one, which means subtract 2. So we're going to be looking for a subtract 2. So here we got plus 3. Not looking for that. Same thing, plus 3, not looking for that. Minus 2, looking good, and minus 2, looking good. So now the last thing we're checking for is it a negative 26 or a positive 26? Now, without even counting, because all these are negatives combined together, it has to be the negative 26. So we're going to go ahead and select the negative 26 based upon everything being negative in here. All right, which set of algebra tiles represents the equation 4x? So first part we're going to check is, do we have 4 x boxes here? So 1, 2, 3, 4. First one looks good. Next one, 1, 2, 3, 4, 5. We have 5 x's there. That is way too many. So the second one is automatically out. The third one looks good. We got 4 x's, but the last one we also have 5 x's just like the second one. Therefore, we don't want the second one or the fourth choice. So next up, we have looking for 5 tiles that are still on the left side. So notice the equal sign. So 5 is on the left side. So here we go. We got 1, 2, 3, 4, 5 tiles. That looks good. And the only other option was the third one. 1, 2, 3, 4, 5. Ooh, there's 6 tiles there. It's too many. So this leaves our choice to be the first choice, to be the correct choice. All right, next up, which equation does this set of algebra tiles represent? Now, notice they have left out our multiple choice. They're now asking us to go ahead and type the equation. But based upon what we've been doing so far, it almost seems easier to just type in the choice rather than to look for it. So here's what we do. We have 3 of the negative x's. And because they're negatives, it's easier to put the negative in the front. So don't put 3 minus x. Just call it negative 3x's because you have negative 3 sets of the negative x's. All right. Equals. We have negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9. So we got negative 9. So minus 9. To me, that just seemed just as easy. We're just typing it in. All right, next one, we have negative x. And if it's just negative x by itself, I'm going to leave it as negative x, literally, negative x, negative x. Because these are positive ones, we have 1, 2, 3, 4 of them. So we're going to add 4. And I'm going to be careful to make sure I use positive 4, not equals. There we go. Plus 1, 2, 3, 4, 5, 6, 7, 8, 9 on the other side. Plus 9. All right, next up we have 2 x's. So when you have 2 x's, I put 2x equals. We have 8 ones on the right side. 2x equals 8. All right, ooh, they're trying to throw us a curveball here, trying to make it a little bit more confusing, but you know what? It's the same thing. First of all, we're starting with all negatives. So we're going to use a negative. we have 1, 2, 3, 4, 5 sets of the x's. So we're going to call that negative 5x. Now we're going to get on to the ones. Because the ones are all negative, we're going to be using subtraction and counting up the number of ones. We have 1, 2, 3, 4, 5, 6, 7. Minus 7 equals. On the right side, we have negatives. So they're all negatives. 3 multiply 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 times 9, there should be 27 negative ones in there. So we're going to call that negative 27. All right, how are we doing so far? We got 9 questions answered. We're 14 minutes in. Just taking our time. We're cruising. 64. We're going up to a smart score of 80 or higher. So next up, we got 3 sets of x's plus 6 ones equals 12. Next up, we have an x. When x is by itself, just call it x. All positive ones, and there's 6 of them, so plus 6. Here we go. I got to be careful with that equal sign and plus. Equals 7 on the right side. Next up, we have 1, 2, 3, 4, 5, 6, 7 x's, so 7x equals, I'm going to use my multiplication here, so I got 3 multiplied 1, 2, 3, 4, 5, 6, and 7. So 3 times 7, I got 21 on the right side. All right, next up, we're going to solve. Ooh, now they're asking us to solve. So close to 80. Now we got to solve. Let's see. What are some strategies? First of all, what does the word solve mean? The word solve means to figure out the value of the variable. In this case, the value of x. So, did you know that if you have a 1 on one side and a 1 on the other side, they balance out. 1 equals 1. Which means we can eliminate that. So for every 1 that we have, or every matching pair, they eliminate. So that one eliminates with that one. Eliminate, eliminate. So we're at 2 and 2, 3, 3, 4, 4, 5, 5, 6 and 6, 7 and 7, and 8 and 8. Okay, now we got x by itself. So notice we're doing something called isolate. The word isolate means to get it by itself. So now what we have is, let's write out everything that we got without the crosses. So we still have 2 x's on the left side equals, well, on the right side, we still have 1, 2, 3, 4, 5, 6 less. So we took this problem of 2x plus 8 equals 14 and simplified it to 2x equals 6. Now, because we're looking for 1x, notice that x by itself means 1. What we need to do is take that 6 and divide it evenly between the 2 x's by dividing 2. So what happens is 2 divide 2 cancels out to x, and 6 divide 2 equals 3. So each set of x's is worth 3. So let's see if that works. We have a 3 here and a 3 there. So now, is it true that we have 3 plus 3 is 6, 7, 8, 9, 10, 11, 12, 13, 14. So we got 14 on this side equals, now hopefully we got 14 on this side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. When you have the equation that is matching on both sides of the equation, then you know you're good. So that was called checking for our work. So we're just checking to see if our answer is correct. So the right answer is 3. But because both sides are balanced, we know that 3 for sure, without even worrying about my score dropping, will be 3. Okay, last problem. We got one more of these. Use algebra tiles to solve 3x equals 6. All right, so notice I do not have the ones on both sides. We only got 3 x's and 1. So what I'm going to do on this one is use something called grouping. So what about putting that x with there, that x to the second one, and that x to the first one? So what I did is I got rid of half my ones for each x. But wait a minute, there's two sets of them. So that can also go there. That one could also go there. And that one could also go here. So notice for every x, there are 2 ones. So 2, 2, and 2. Well, it works out. 2 plus 2 plus 2 is 6 equals 6 ones is 6. So it makes sense that x has a value of 2 of the 1 blocks. So for x, we're going to go ahead and put 2. All right, this concludes our IXL for W3, modeling and solve equations using algebra tiles. Take your time on this one. It's kind of fun. You're just reading the puzzle and writing it out. But you can do it. Have a great day.